let's see section 10.4, solving combined inequalities. I hope you guys had a good day today. I missed you. I was over at the Perot checking things out over there for a field trip that I'm going to do with the 6th grade, but you guys don't need to worry about that. We're solving combined inequalities today. So what we have been doing, we had just one inequality and getting the variable on one side or the other by itself. But now we're going to do something today called combined inequalities. And in this first little slide, just bear with me for a moment. We're just going to be looking at some information. A combined inequality joins two inequalities, okay? So if we look down here, it says if a number can be a solution to both inequalities, we call the combined inequality an AND statement. It's also known as a conjunction. So let's look over here at this graph, okay? When we look at this graph, this inequality is x is greater than or equal to 3 and less than 4. Now there are numbers that satisfy both of those things, like 3.5. 3.5 is greater than or equal to 3. It's also less than 4. So you see, this joins two inequalities, and there's a number that can be a solution to both of them at the same time, okay? And when we graph it, it looks something like this blue graph that we have right above here, okay? And this bit in the middle here, this is shaded. This one's shaded because it can be equal to 3. This one's left open because it can't be 4. But because you shade between these two critical points, this is called a conjunction, okay? They're added together, all right? Now let's go down here. We're going to look at what's called a disjunction, all right? Get down to the green part here. It says, if a number can be a solution to one inequality or the other, but not both, we call the combined inequality an OR statement, also known as, aka, also known as a disjunction, okay? So let's look at this disjunction compound inequality. It says that x can be less than 2 here, or x can be greater than or equal to 5. Now there are no numbers that satisfy both of those at the same time, okay? If we graph them, you can see that the 2 is open because it can't be equal to 2, and then we're shading in this direction, okay? Over here on the right, we do shade in 5 because it can be equal to it, and it's got to be greater than that. There are no numbers that sit here and here at the same time, okay? There are no numbers that are in both of these shaded regions. That's why this is called a disjunction. When the graphing goes away from the two critical numbers, it's a disjunction. When it's between the two critical numbers, that's a conjunction, okay? Now, we're going to spend a few minutes looking at two examples, one of a conjunction and one of a disjunction. I want to show you how to solve these things, all right? So let's look at example number 1. It says, solve the conjunction. Negative 3 is less than or equal to x minus 2, which is less than 4, and graph its solution set. Now, since it's a conjunction, I know that that the solution works for both at the same time. I'm going to rewrite it. Negative 3 is less than or equal to x minus 2, which is less than 4. We want to get the x by itself, so I have to add 2 to make it go away. But to do that, I have to add 2 to this side and this side. Okay? So that's going to give me negative 1 is less than or equal to x, which is less than 6. Okay? So that means that for x minus 2 to be greater than or equal to negative 3 and less than 4, that means that x has to be greater than or equal to negative 1 and less than 6. Okay? So let's graph this. I know my critical numbers are going to be negative 1 and 6. I'm going to put circles around them. Okay? Be sure to put the small number on the left and the bigger number on the right. Okay? I know that it can equal negative 1 because it's got the little or equal to part there, so I'm going to shade this in. And I know that x is greater than that. Okay, now I'm going to stop right there just for the moment. Then I'm going to come over here. I know that the circle over the 6 has to be left open because it doesn't have an equal to sign underneath the less than. and I'm shading this way. And do you see how the shading part matches? That's how I know it's a conjunction. Okay? Any spot, any number in here, let's just pick 3. That number is between -1 and 6. That means if I plug in 3 here, I'm going to get -3 is less than or equal to 3 minus 2 is 1, which is less than 4. Is that true? Sure. 1 is greater than or equal to -3 and less than 4 at the same time. That's how I know that this is a conjunction. Okay? All right. Now, let's look at the next one. Now, in this compound inequality, they say solve the disjunction. There's the or statement right between them. Okay? And when I'm doing a disjunction, when I see that or statement, that means I need to solve these things separately. Okay? So I'm going to work on this one and on this one, but separately. So let's do 2w minus 1 is less than 3. Let's do that one first. We're going to add 1 to both sides, and I'm going to get 2w is less than 4. Then I'm going to divide both sides by 2, and I get w is less than 2. Okay, I don't want to graph yet because this is a compound inequality. This is only part of the solution. Okay, now let's come over here. In this one it says 3w is greater than or equal to w plus 10. Well, the first thing I'm going to do is get my variables together. So I'm going to subtract w from both sides, and I'm going to get 2w is greater than or equal to 10. Then I'm going to divide both sides by 2. Wait, did I divide by a negative or a positive? A positive. Okay, so I don't need to flip the inequality sign. And I'm going to get w is greater than or equal to 5. Okay, now, let's go down here and let's graph this solution set. Here's my number line. Remember, we always put the smaller number on the left, that's going to be 2, and the bigger number on the right, that's 5. Okay? And I'm going to put circles over them. I'm going to graph it in blue. Put a circle over this one and a circle over this one. Let's deal with this part first. Can it be 2? No, because it doesn't have the little equal to symbol underneath. So w is less than 2. That means I shade in this direction. Remember, with a disjunction, the shadings go away from each other. Over here, it does have the little or equal to symbol, so I'm going to color in the 5, because it can be equal to 5. And it says that w is greater than that, so I'm going to shade in this direction. This is a disjunction. Oh, misspell that. Disjunction, because they go in separate directions. All right? Okay, I think you're ready. That's some good looking stuff. I can't think of anything else you guys need to do. I think you're ready. All right. See you later.